Oh, hello, good morning. In last lecture, we discussed the types of the flow, types of the fluid. There are 5 to 6 types of the fluid: real fluid, ideal fluid, Newtonian fluid, non-Newtonian fluid, ideal plastic fluid, and Bingham plastic fluid. These are the various types of the fluid. And when the shear stress is directly proportional to the velocity gradient, shear stress is directly proportional to the velocity gradient is called as a Newtonian fluid. This one. The shear stress is directly proportional to the velocity gradient is called as a Newtonian fluid. This velocity gradient, alternative name for the velocity gradient is a shear strain.
Shear strain.
Shear strain. Okay. And if the shear stress not directly proportional to velocity gradient, the type of the fluid is called as a non-Newtonian fluid. If fluid not obeys the Newton's law of viscosity, that type of the fluid is called as non-Newtonian fluid, real plastic fluid, ideal solid fluid, ideal fluid, etc. If the shear stress is not directly proportional to velocity gradient, and if shear stress is directly proportional to the velocity gradient, the type of the fluid is called as a Newtonian fluid. These are the various types of the fluid we discussed yesterday. Today we discuss the various types of the pressure measurement. Fluid pressure measurement. What are the different types of the pressure? Different types of the pressure: atmospheric pressure, gauge pressure, absolute pressure. This figure is represent the relationship between the pressure. The absolute pressure, absolute zero pressure, that is a horizontal line. Absolute zero pressure is a horizontal line, and pressure on this y-axis. If the pressure is zero, it is called as absolute zero pressure. And atmospheric pressure, this another horizontal line, this is called as atmospheric pressure. And you know the value of atmospheric pressure, that is 1 atmospheric pressure is 101.325 kPa. kPa is a kilopascal. 1 atmospheric pressure is equal to 101.325 kilopascal, and we already know the Pascal conversion. What is the Pascal conversion from Pascal to Newton and meter square? What is the conversion? 1 Pascal is equal to 1 Newton per meter square. So kilopascal, this Pascal is replaced by Newton per meter square. So K as it is, that is a kilonewton per meter square. Another conversion for 1 atmospheric pressure is 760 mm of Hg, 760 mm of mercury. And in terms of water column, that is 10.33 meter of water. In terms of the mercury column, 760 mm of Hg. There are 3 types of the conversion for 1 atmospheric pressure. Keep in mind, the first one is 1 atmospheric pressure is equal to 101.325 kilopascal or 101.325 kilonewton per meter square. In terms of the mercury column, its value is 760 mm of Hg, 760 mm of mercury. And in terms of water column, that is a 10.33 meter of water. These are the 3 unit conversion required for solving the numerical. Which one is the SI system unit out of these 3? Which one is the SI system unit out of these 3 conversion? Can anybody tell me?
Kilonewton per meter square.
Okay, first one. The first one is a SI system unit. In SI system unit, we need to consider this value. Okay, the first one. Again, we need to convert kilopascal to Pascal. That is SI, actual SI system unit. Kilopascal to Pascal. What is conversion kilopascal to Pascal? 1 Pascal is equal to 10 to the power minus 3 kilopascal. 1 Pascal is equal to 10 to the power minus 3 Pascal, kilopascal, and therefore 1 kilopascal is equal to how many Pascal? 1000 Pascal. That is 10 to the power 3 Pascal. 1 kilopascal is equal to 10 to the power 3 Pascal, and 1 Pascal is equal to 10 to the power minus 3 kilopascal. Is it same as a gram and kilogram? Same as gram and kilogram. 1 kilogram means how many gram? 1000 gram. Similarly, 1 gram means how many kilogram? 1 gram means 10 to the power minus 3 kilogram. 1 gram is equal to 10 to the power minus 3 kilogram. The conversion is same as a gram and kilogram. These are the horizontal line. Second horizontal line is representing the atmospheric pressure. And if the pressure above the atmospheric pressure, and if pressure below the atmospheric pressure, if pressure above the atmospheric pressure, that is called as a gauge pressure. If pressure value above this value, if the value of pressure greater than 101.325 kilopascal, that type of the pressure is called as gauge pressure. Okay, and if the value of pressure below this value, below 101.325 kilopascal, that is called as a vacuum pressure. Okay, the gauge pressure, that is called as a pressure above the atmospheric pressure, and vacuum pressure means pressure below the atmospheric pressure. Okay, and based on this, there are 3 different types of equation of the absolute pressure. So P suffix ABS is called as a absolute pressure. It's called as absolute pressure, and this absolute pressure is the atmospheric pressure is a common. Atmospheric pressure is the common term, plus or minus gauge pressure. Plus or minus gauge pressure means if the pressure above the atmospheric pressure is called as a gauge pressure. If pressure below the atmospheric pressure is called as a vacuum pressure. And if the value is plus is represent the gauge pressure and minus is represent the vacuum pressure. As far as this first equation, P absolute is equal to P atmospheric pressure plus or minus gauge pressure. Gauge pressure may be plus, may be minus. Okay, if it is minus, that is called as vacuum pressure, under pressure, and over pressure. Plus means over pressure, minus means under pressure. Okay, so you can consider one example, that is a balloon. Okay, if we insert the air in the balloon, what happen? Size of the balloon will be increase. It means that pressure inside the balloon and pressure outside the balloon, which pressure is higher? In case of the balloon, inside the pressure inside the balloon and pressure outside the balloon, which pressure is higher?
Inside the balloon.
Inside the balloon. Pressure inside the balloon is higher. Okay, and if we consider another example, 4-wheeler. Okay, in case of the 4-wheeler, the wheel, we need to air whatever the pressure in the tire and pressure outside the tire. Okay, which pressure is higher?
Inside the tire.
Inside the tire pressure is higher. Outside the tire, which one is the pressure? Outside the tire, that is atmospheric pressure. Outside the tire, that is atmospheric pressure. Inside the tire, the pressure which is greater than atmospheric pressure. Inside the tire, the pressure is greater than the atmospheric pressure. That is called as the gauge pressure. And suppose in case of tire, if we remove the ear, from the tire as well as balloon, what happen? The size will be reduced, will be decreases because of the pressure inside the tire and pressure inside the balloon will get decreases. And if the pressure get decreases, then atmospheric pressure, its size get compact. That is example of the vacuum pressure. If we consider one bottle, flexible bottle, if we consider one of the flexible bottle, and if we remove the ear from that flexible bottle, what happen? The size of the bottle will be changed. If we take the flexible bottle, remove the cap of that bottle, what happen initially? It is a round shape bottle, or whatever the shape of that bottle it is as it is. And if we remove the cap and remove the ear from the bottle, what happen? Size of the bottle will be changed. If we remove the ear from that bottle, the size of bottle will be changed. Compact. Due to which pressure? Due to vacuum pressure. Pressure in the bottle will be removed. That is called as a vacuum pressure. The size of the bottle will be changed. It means that pressure inside that bottle and pressure outside the bottle, which pressure is higher? If we remove the pressure in the bottle from the bottle and close that bottle by using cap, which pressure is higher? Inside
Outside
the
the
bottle or
bottle.
outside the bottle?
Outside the bottle.
Outside the bottle pressure is higher. That outside the bottle pressure is higher. That value is atmospheric pressure. And pressure inside the bottle is less than atmospheric pressure. That's why that size of the bottle will be contract. Is it? That is called as vacuum pressure. So what are the three relation of the pressures? Absolute pressure is equal to atmospheric pressure plus or minus gauge pressure. And these next two equation will be just expansion of this first equation. That is plus gauge pressure and minus vacuum pressure. So P absolute is equal to P atmospheric pressure. P absolute is equal to P atmospheric pressure plus or minus gauge pressure. Second equation, P absolute is equal to atmospheric pressure plus gauge pressure. And next equation is P absolute is equal to atmospheric pressure minus vacuum pressure. Minus vacuum pressure. Is it? If we measure the pressure in the tire, okay, which of the instrument is used to measure the pressure in the tire? Which of the instrument to measure the pressure in the tire? It may be four-wheeler, it may be two-wheeler, it may be cycle. Okay, which instrument is used to measure the pressure in the tire? Pressure gauge. Okay, which instrument is used? That is a pressure gauge. Is it correct? Or any other instrument is used? Pressure gauge is used to measure the pressure inside the tire. If we observe the reading, whatever the reading mentioned in that pressure instrument device, pressure gauge, start from 0. Have you observed it? Start from 0. That 0 is called as which pressure? That 0 is represent which pressure? In the pressure gauge. Whatever, which pressure? 0 is represent which pressure?
Absolute pressure.
Atmospheric pressure. 0 is represent the atmospheric pressure, and whatever the pressure greater than the atmospheric pressure, that is a gauge pressure, and that gauge pressure is represent, that gauge pressure shown by the gauge, and that atmospheric pressure, it represent the 0 in the meter, gauge meter. So that combined pressure is called as a absolute pressure. Initially, pressure gauge pressure meter shows the atmospheric pressure, and whatever the pressure increases in the tire, we fill the air in the tire, the pressure get increases. from the atmospheric pressure, that is called as gauge pressure. So pressure in the tire is a absolute pressure. It means that atmospheric pressure plus gauge pressure. Is it understood? The difference between gauge pressure, vacuum pressure, and absolute pressure. What are the three types of pressure? Absolute pressure, atmospheric pressure, and gauge pressure. This is a conversion. One atmospheric pressure is equal to 101.325 kilopascal. That is called as kilonewton per meter square. In terms of mm of Hg, what its value? In case of mm of Hg, its value is
760.
760 mm of mercury. And in case of the water column,
10.33.
10.33 meter of water. Water column and mercury column, it means, see, in this figure is represent the U tube. This B is called the circle, and there is a mention the B inside the circle, and that is called as a pipe. And this pipe, the U tube is connected. U-shaped tube is connected. Okay, in this U-shaped tube, there is a mercury. This color fill is represent the mercury. Okay, and pressure inside the pipe is represent. Okay, inside the pipe there is a liquid. There is fluid inside the pressure inside the pipe. It appears some pressure. It exerts some pressure on the mercury. It represents certain pressure on the mercury, and that height of the mercury below the datum line. Okay, in this figure there is a slight mistake happen. I will show you different figure. See this one. Is it visible? This figure?
Yes, sir.
Yes, sir.
Okay. See here pipe. Inside the pipe there is a pressure PA. Pressure in the pipe is PA. This is a fluid flowing through the pipeline, and this color is represent the mercury inside the U tube. One of that U tube is open to the atmospheric, open to the atmosphere. U tube, one of the end is open to the atmosphere, and one end is connected to the pipe. One end of the U tube is connected to the pipe, and another end of U tube is open to the atmosphere. Okay, as far as this figure is considered, it's called as left limb. This is a left limb and this is a right limb. Left limb and right limb. Okay, if the pressure inside the pipeline, if pressure exerted by the fluid inside the pipeline is 0, okay, pressure inside the pipeline is 0, what happened on the level of mercury? There are two horizontal lines shown, A dash and B dash. B dash, A dash. If there is no pressure inside the pipeline, what happened on the level of mercury? The level of mercury on left limb and level of mercury in right limb, is it at the same level or different level? If there is no pressure inside the pipe, if there is no pressure inside the pipe, then level of mercury in the U tube, is it at the same height or different height? Same height. If there is no pressure inside the pipeline, then level of mercury will be the same height, at the same height. And if pressure exert in the pipeline, then this fluid is exert the pressure on the mercury and push the mercury in downside, and at the same time level of mercury goes off on the right limb. If pressure exerted in the pipeline, then that fluid exert the pressure on the mercury, therefore mercury pushed down from the left limb, and at the same time mercury goes off in the right limb. Okay, therefore there is a level difference of the mercury, where the level is lower and where the level of mercury is higher in the U tube. Level of mercury, where is it lower and where is higher in the U tube? The left limb level of mercury is lower, and as far as the right limb level of mercury is higher. So level of mercury, where the level of mercury is lower, just mark the horizontal line. Where the level of mercury is lower, mark the horizontal line, and that horizontal line is called as datum line. Is called as datum line. And again, there is a level of upper level of mercury. Again, mark one horizontal line, but that is not the datum line. This line is not the datum line. Here mentioned, this line is not the datum line, but below line, the level of mercury, lower the level of mercury, pass the horizontal line where level of mercury is lower. That line is called as a datum line. Make it clear. Which one is a datum line? If mark the horizontal line, start from the surface of mercury in the both limb. This right limb surface of mercury is here. Mark the horizontal line. As far as left limb, this level of mercury, mark the horizontal line. There are two horizontal line. From these two horizontal line, which one is a datum line? Lower side is a datum line. Always consider the lower side is a datum line. Okay. As far as this figure, which one is a datum line? Suppose there is a this another datum line. I will just insert line for understanding purpose. So tell me what this line is represent, datum line or not? As per this figure is considered.
The
This-
lower line is represent datum line.
This upper line is a represent red color, and this bottom line is represent A dash. So out of these two, which one is a datum line?
A dash.
A dash is a datum line. Why A dash is a datum line? Because of
Lower side.
lower level of mercury.
Hmm.
In which limb? Right limb or left limb?
Left.
Left or right limb? Level of mercury.
Right limb.
See, which one is the right limb and which one is the left limb? Right side is a right limb, left side is a left limb. Right side is a right limb, left side is a left limb. So as far as this figure is concerned, in which limb level of mercury is lower?
Right limb.
Right limb. So therefore, this one is a datum line. And as far as this figure is considered, which one is a datum line? I will mark one line here just for understanding purpose, and you tell me which one is a datum line.
A dash is the datum lines.
Observe carefully. I was initially told you some mistake happened. There are these three lines. Okay. This you can call it as a this three different lines. This A dash, this line pass through level of mercury, lower side of level of mercury in the left limb. This line pass through the surface of mercury from right limb. So there are three horizontal lines as far as this figure is concerned. Which one is a datum line? A dash, this middle line or upper line? Which one is a datum line?
Middle line.
Middle line is a datum line or lower line is a datum line? Or upper line is a datum line? Make sure. If you clear this concept, 50% of numerical part is finished based on this concept. If datum line is shown correctly, then numerical will get at least 50% solved. Which one is a datum line? We have in this figure three lines, A dash, this middle line and this top line. What is meaning of datum line? The datum line pass through the lower level of mercury in the U tube. Datum line
Middle
should be
line.
passed through lower side of mercury in the U tube. It may be left limb, it may be right limb, lower side of mercury in the U tube. So tell me, out of these three lines, which one is a datum line?
A dash.
A dash. Any other? Tell me which one is the datum line?
Middle line, sir.
Why middle line is a datum line? Can you justify it? Lalit, can you justify it? Why this middle line is a datum line?
Because it's showing the lower side of Mercury.
Yes. The middle line is a datum line because this middle line is passed through lower level of mercury in the manometer. Where the lower level of mercury in the manometer? I will show you the three different conditions here. This text box. We'll mark here the B. Okay. Is B, and this one is a C part. Is this figure visible or not? Is the figure visible or not? Tell me.
Yes,
Visible,
sir.
sir.
Visible.
Okay. This BB, line B, line C, and line A dash. A dash. So A dash is the lower level of mercury. This line is passing through lower level of mercury. This A dash.
No, sir.
No, means this is not the datum line. C, line C passing to the lower level of mercury.
Yes, sir.
Okay. Line C is passing through the lower level of mercury. Line B is passing through lower level of mercury as far as this U-tube is concerned.
No,
No,
sir.
sir.
No. So there is only one line passing through lower level of mercury, and that is which line? Line C. So line C is a datum line. Line C is a datum line. In this figure, there is a mistake. Which mistake? This line is not required. This line is not necessary. Okay. Because this is not the line passing through lower level of mercury. This line passing somewhere in the manometer. Okay. This line is not required as far as this figure is concerned. Okay. This one is another figure. So make it clear how to identify, how to draw, where to draw the datum line. Is it clear? If you clear this concept, the
Yes, sir.
50% numerical part is over. Is it understood or not? Or shall I repeat it again? Shrutika, Gaikwad. Is it understood? Shrutika, Srushti, Lalit.
Yes, sir.
Yes,
Is it understood?
sir, it is understood.
Yes, sir. Understood.
Okay. Then there is a represent the height of the water column. This represent this color is represent the water column, water, height of the water in the pipeline. This U-tube. Okay, this one is U-tube. And then there is a B line and A line. Out of these two, which one is the datum line? We already discussed. Tell me which line is the datum line out of
A
A
line.
dash and BB dash.
A line.
Line A dash is represent the datum line. I here mentioned that this is a datum line and this is not the datum line. Okay. Then from this, again, there is one more line. This line, we can call it as a line. D, you can call it as D. So this D is represent which line? This line passing through the center of pipeline. Line D is passing through center of pipeline. Okay. This pipeline, this circle is represent the pipe. Okay. And center point of this pipeline and line passing through that center point is represented DD. D dash. DD dash is represent the line passing through center of pipeline. Line BB dash is passing through level of mercury in right limb. Line A dash is passing through level of mercury in left limb. So out of these three lines, DD dash, BB dash, and AA dash is a datum line, and D dash is line passing through center of pipeline. And then measure the distance from the center of pipeline. Measure the distance of center of pipeline from the center of pipeline to these two lines. Okay. As far as this D line and this B line, line DD dash and line BB dash, the distance between line D dash and B dash, what is height or distance? Distance between
H1.
line D and B, what is distance?
H1.
H1. H1 is represent height of water. H1 is represent height of water above the line B to the center of pipeline. H1 is represent height of water above the line B till center of pipeline, or H1 is represent height of water below the center of pipeline till line BB dash. Is it clear? H1 is represent height of water. This one is water. This color through the pipeline is represent the water, and this H1 is represent height of water in the left limb, height of water in the left limb from the center of pipeline till BB dash. So can anybody tell me height of water in left limb between the BB dash and AA dash? What will be the height of water between the line BB dash and AA dash?
H2.
H2, correct. H2 is represent height of water in the left limb between these two lines, AA dash and BB dash. Okay. So what will be the total height from the center of pipeline to the datum line? What will be the total height from the center of pipeline to the datum line of the water column?
H1 plus H2.
H1 plus H2.
H1 plus H2 is represent height of water from the datum line to the center of pipeline. Okay. Can anybody tell me what will be the height of mercury from the datum line? Height of mercury from the datum line. Height of mercury from the datum line in right limb. In right limb, height of mercury above the datum line. This is datum line. So above the datum line, what will be this height of the mercury?
H2.
Again H2, correct? So H2 is represent height of mercury above the datum line. H1 plus H2 is the height of the water above the datum line. Height of water above the datum line. So this is datum line. This A dash is a datum line, and here mention the pressure above the datum line. Pressure above the datum line on left limb as well as right limb is same. Pressure above the datum line is same on both sides of the manometer. Okay, this is the manometer, U-tube manometer. One end is open to the atmosphere, another end is connected to the pipe, and pressure above the datum line. Pressure of this mercury level is we can call it as a mercury level is stable at this BB dash, at this point B is line passing through the this mercury surface, that is called a BB dash. So level of mercury is stable now. So pressure on the left side of the mercury, left side of the manometer, and pressure on the right side of the manometer above the datum line is same. This datum line and pressure above this left limb and pressure above this right limb is same. That statement is mentioned. The pressure above the datum line is same on both sides of the manometer. Okay. And how we can find out that pressure above the datum line? I will show you the different figure. Then we can get the idea. Is this figure visible?
Yes, sir.
We can consider it as a bucket, and in that bucket there is a water. Okay. The level of water, we can mark it as a distance here. This height, and we can call it as a this h1, and this one height is a h2. Again, This represent A, and this A is represent one particle, one molecule, water molecule, and here is the water. What is the height of water? Height of point A from the surface of water. What will be the height of point A from the surface of water?
H2.
H2 is a height of this point A from the surface of water, H2. And what will be the height of this point A from the surface of bucket? We can call it as bucket. From the bucket surface. This is bucket surface. What will be the height of point A from this surface? You can call it
H1
as
plus H2.
H1 plus H2.
H2.
H1 plus H2. And we need to find pressure at point A. Pressure at point A. How to find the pressure at point A? There is one formula that is called as density acceleration due to gravity and height. Height of point from surface of liquid. This is a formula to determine the pressure at point A. The pressure at point A. Okay. We can call it as the datum line. Which in datum line? This one is a call. Is C point C dash. And this C dash. Can call it as a datum line. Is it understood? The lower level of point A. There is a one more point. This point is called as a B. 2 point, and again mark one more line to represent height of point B from the surface of liquid and this height is represent as a H3. H1, H2, H3. Okay. As per this formula is considered. Which formula? Pressure at point A is represent. What is the formula?
Density into gravity into height of point from surface of liquid.
Density of liquid. Your density means density of liquid. Which liquid is available here?
Water.
Water. So to find out the pressure at point A, what will be the equation? We can consider density of water is Density of
1000.
liquid, you can call it a density of water. Gravity, we can call it as a G notation. What is value of gravity? Acceleration due to gravity?
9.81.
9.81, correct. And density of water, what is the density of water?
1000.
We can call it as density of water only. Then multiplied by height of point from the surface of water. What will be the height of point A from the surface of water?
H2 plus H3.
Observe carefully.
H2.
H2, correct. H2. Similarly, you tell me the surface pressure at point B. Pressure at point B. Pressure of liquid at point B. Formula is again same. Density of liquid into gravity into height of point from the surface of liquid. Can anybody tell me? Point pressure at point B. What is the height from the surface of liquid?
H3.
H3, correct. So what will be the formula? Density of water, correct. Multiply by tell me, density of water multiply by gravity, again multiply by height. Height is a H3. Height is H3. So basic common formula as far as notation wise, its formula is rho GH. We can call it as general formula. General formula is equal to rho GH rho into G into H is a general formula to determine the pressure. Is it clear? Is it understood? What is the general formula to determine the pressure?
Yes, sir.
Tell me general formula to determine the pressure at that point.
Rho into G into H.
Rho into G into H. What is meaning of rho?
Density of water.
Rho is density. Whatever the liquid is available, density of that liquid. What is my G?
Acceleration due to gravity.
Acceleration due to gravity. And what is my H?
Height of point, surface
Height
of
of the
liquid.
point. We can call this height is a height from the surface to the datum line. We can call it as this H is called as height from the surface to the datum line. This is called as a datum line as far as point B is considered. This is lower level. We can call this point B as a datum line. If we consider point A, this is called as a datum line. If we consider point B, this is a datum line. Means H is represent height from the surface of the liquid. Height from the surface of liquid till that point. Okay, as far as this manometer is considered, this H1 is represent height from the surface of the liquid. Instead of surface of liquid, here center of the pipe. Here the center of the pipe till the surface of mercury. This is point, suppose here point B and here point A. This point is B, this point is A. What is the height of point A from the center of pipeline? If we consider this as a point A,
Yes.
H1 plus
H2.
H1 plus H2. If you consider here point B as per this figure, see this point B, you can consider this as per same figure. This point is B. What will be the height of point B from the center of pipeline?
H1.
H1. Okay. And here pressure above AA on the right limb, right side. Pressure above AA on right side. This is right side. Above the AA. What will be the pressure above the AA from the right side? Pressure above the AA on right side means this height. We consider this height. Rho G is a common. Rho GH. Formula here mentioned. Rho GH. Here again rho GH. This part we discuss in next lecture. Okay. As time is over. Is it understood?